Hi, everyone. My name's Megan,
I'm Jack.
and we're from Google Cloud DevRel, and we're excited today to be talking through agent tools. This is a super exciting and also sometimes confusing topic, and so we're coming to you today with kind of a big code example and some key things to know about agent tools, especially when using them with Agent Development Kit or ADK. Uh, the example that we'll be using today is about software bugs. So imagine that you're a project or a program manager at a big company and you spend your days in GitHub and bug databases and Jira, StackOverflow, you name it. And it can be a lot. It can be a lot of context switching. You're working with different interfaces, different people all day long, and it can be quite overwhelming. And so we're kind of using this as an example of a ripe use case for an agent where we could pull together all these different data sources, APIs, and tools into one pane of glass and use natural language to do some of our day-to-day tasks. So yeah, just to recap, I guess like Jack, you want to walk through like how do you kind of think about like what an agent is and where do tools fit in?
Yeah, totally. So I think really there's kind of three components to an agent. You've got your model. So we'll be using Gemini 2.5 Flash, I believe, in our example today. But this could be any model. There's Anthropic models, there's OpenAI. This could be any provider. And then you've got your instructions. So that's basically how you're telling the agent how it's going to behave. In today's example, we'll be doing like a software bug assistant. So it's going to be taking on that persona, that set of instructions so that it knows how it should behave. And then there's also the tools. So this is kind of how you actually allow your agent to do things in the world, whether it be, call certain APIs, run custom code, these kind of things, kind of giving it the ability to do tasks on behalf of the agent.
Yeah, totally. And I guess in terms of like how tools work, I think this for me, I don't know about you, Jack, like this can be where I get really tripped up in terms of what is the role that the model's playing and where is the agent framework working? Like, could you walk through kind of how you think about that workflow?
Yeah, so normally you will have your set of instructions and your tools, whether that's doc strings, they'll kind of tell the agent what that tool does. It'll have its parameters. It'll kind of tell the agent what it's able to do. And then it's actually the model. So the model is kind of the brain. It's actually going to go ahead and actually from those descriptions, it's going to do that reasoning and figure out what tool it needs to call and when. So that's kind of how it pieces together. I'll let you add anything you want there if I missed anything.
Yeah, no, that's a great way of phrasing it. I think the thing that trips me up so much is the term function calling or tool use, because when talked about in the context of like LangChain or ADK, it's not actually about using the tool. It's like formatting the request because like the code, like the actual execution environment, the framework, that's what calls the tool. And then the model processes the output. So it's this really interesting handoff that you have, like when you have an agent with tools. But yeah, wanted to cover that like straight up because it's a gotcha. Yeah, so what we'll do during this video is we're going to walk through a couple of ADK tool types as kind of examples of ways that we can add tools to this bug assistant agent. And we're going to be covering a couple. We're going to start with the most simple and kind of work our way up. We've got our code and our agent pulled up here. And so the first is the function tool. Jack, like, how do you think about function tools and what's kind of the one you've added here?
Yeah, we'll start with the function tool. It's kind of the first place to start, and it is kind of how the name, it states it for you. It is essentially a Python function that you will just pass as a tool to your agent. So for our example here today, agents don't always have all up-to-date information. They have, a cutoff date where their knowledge is cut off. So if you actually ask an agent, what is the date today or something like that, it might actually give you an outdated response. So we can actually use this in our bug assistant. This will come in really handy because we want to know, what bugs have been opened in the last day, in the last week. So we can use a function tool here, a Python function that just quickly, uses the date time Python package, and it just gets today's date. And that's going to really help, then our answers can actually have that information and we can go from there.
Yeah, absolutely. And you'd see it's kind of a preview on the left here of how many tools we're going to be working with. But the one that we just invoked here was get current date, so that function tool. And then we then used it to actually call our bug database, which we'll get to in just a second. Awesome. Thanks, Jack. So that's the function tool. ADK also supports like long running functions, and it has this cool feature where it will give like an initial response and then run in the background. So if you have things that you don't want to wait on like synchronously, that is an option as well. Okay, let's cover built-in tools. So Jack, do you want to run through that one?
Yeah, so built-in tools are really cool. They're actually built-in capabilities to the models themselves. So we're talking about the Gemini models here. So they have some really handy built-in tools, and this is kind of surfaced through ADK's terminology of a built-in tool. And one of these is the ability to actually Google search. So they have the capability to actually go ahead and query things through Google search. And this really helps to ground your answers again in relevant data. If things have happened recently, we can go ahead and actually search the web and pull those into our model. There's also built-in tools like code execution. So if you want to have the model actually, write some code and execute it, it can do that as well.
Yeah, absolutely. And yeah, I think the key thing to know is that most of these work with the Gemini 2 model. So again, they're relying on kind of the model's features here. And yeah, so in our case, what we're using here is the Google search tool, so that if we ask like help debug a PDF export issue by searching the web, just to make sure we do get that tool call, we're going to have that search agent run, and that's going to be doing a Google search for us.
I think the one thing to point out here too is we're actually using agent as a tool here for our Google search. And this is another kind of built-in capability of ADK. It lets you actually kind of create a tool that it actually just invokes another agent, essentially calling that agent as if it were calling a function. And then once it gets that response back, it just hands it back off to the current agent. So it doesn't actually hand off the delegation. It's basically just using that second agent as a function.
Yeah, that's a really good call out, Jack. And it should be set for like full transparency. Part of the reason we have this in here is because there is an ADK bug that's preventing the use of a built-in tool when you have many tools like we do here. But what I think is cool to call out is that when you have an agent tool, you can essentially have like sub instructions. So we could say like you're a specialist in Google search. Like if the user's asking for like a root cause, you should add these types of queries to your search or operators. So it actually can be really powerful to have this kind of setup. Nice. Okay, that's the built-in tool. Okay, third-party tool. So let's talk about that.
Yeah, third-party tools are essentially a way where we don't want to isolate people to only using ADK tools. So this is where we can actually use third-party tools. This could be other orchestration frameworks like LangChain or Llama Index. They have their own kind of classes for tools. So ADK allows you to pull these into your code if you already have, I've already written the code for a LangChain agent and you're now using over to ADK, you can actually use tools that have already been written for LangChain. And there's really nice ecosystem in LangChain community where they actually have community written tools. So there are actually, I would say like almost 100 different community tools that people have written and are in the community. And you can go ahead and pull these in into your ADK agents. They're already pre-built. We'll see right here, we're going to be using Stack Overflow or Stack Exchange to actually go ahead and query Stack Overflow to see, in our case, if we run into an issue or a bug, we can go ahead and ask, has anyone else seen this before? And this is really just 2 lines of code. We take the Stack Exchange tool from LangChain, and then we just wrap it in the ADK LangChain tool class, and then it's exposed to our agent.
Yeah, I think this is such a powerful feature of ADK, as you said, Jack, because there are such large communities of tools that predate things like MCP that we're about to talk about, and people have just like wrapped APIs in really helpful ways, and we can just grab those tools and use them here. And so that's been really a cool thing that we've added to this agent here, because yeah, I'm on Stack Overflow all the time, and I imagine other folks are too. Awesome.
Exactly.
So that's the third party tool. So this brings us into what I think is like one of the tougher concepts around tools, and in part because it's changing really fast. And this is a protocol called MCP. So what is MCP? So I'll try to take a stab, Jack, but please interrupt me. So MCP stands for Model Context Protocol. It is a tool protocol that was introduced by Anthropic last year in 2024. And it's all about the use of tools within not only AI agents, but also AI applications. Think, I don't know, like Gemini Code Assist, Windsurf, Claude Desktop, like all of these user-facing apps. how do they invoke tools? Well, think about an API like GitHub. So before you'd have to write a bunch of client integration code, auth stuff, retry logic, and everyone integrating with GitHub has to write some of that code. It's integration code. That adds a lot of toil. And so the idea would be that an API or platform developer or provider or anyone really could write something called an MCP server. It's almost like a proxy between that AI agent or an app and the tool. And the actual tool call happens between an MCP client and an MCP server. So in ADK, we'd have an MCP client that would then call a server. Jack, did I miss anything there about MCP?
No, you did a great job. I think the one thing I think that really highlights the strength of MCP is like we just previously talked about. Tools could be written in one orchestration framework, or even in language in Python, and then we're using a different orchestration framework. We'd have to rewrite, the wrapping code around our database or around our API. We'd have to write it in Python and Java. MCP really bridges that gap so that you can just write it using the standard protocol once, and then you can connect to it, like you said, from your different MCP hosts, from different programming languages. So it really simplifies it where you can just write the code once and then connect to it from anywhere.
Yeah, absolutely. Yeah, I'm also imagining we're about to dive into the GitHub MCP server and imagining that the GitHub team decides to change something about their API, maybe something in the endpoint or the request body changes. That MCP they handle that code rewrite on their side, but all we see is search issues that hasn't changed, and so it can add stability in a landscape that is changing so quickly, like agents. Yeah, so we're going to explore two different MCP servers today in our bug agent. The first is the GitHub MCP server. So shout out to the GitHub folks for not only building a really comprehensive MCP server, but recently launching remote MCP support. So we don't cover this a ton here, but remote MCP support allows you to call in a MCP server that's running outside of your immediate runtime environment versus running locally on your machine. And so they actually have a hosted MCP server that you can auth to, which is what we're going to use here. So Jack, do you want to run through kind of how we're using the GitHub MCP server here?
Yeah, exactly. So what you said, we're using the remote MCP server from GitHub, and we're actually it uses the new streamable HTTP transport. And this can be easily brought into ADK through the MCP Toolset class. So we just go ahead and initialize our class. We do our streamable HTTP connection parameters. This is where we pointed at the remote URL. And then we pass in our header. So like you said, this is a remote server, so we need to authenticate to it, essentially say who we are. Here's our GitHub personal access token. That way, if later on I say, can you list the issues assigned to me? It knows that I should go get the issues for Jack and assign those. And then I want to call out just the last thing here at the bottom, the tool filter. This is another nice feature of ADK where MCP servers can have hundreds of tools, and we don't necessarily always want to have those exposed to our agent. So what we're doing here is we're using the tool filter to actually filter down and only have the issues or the tools that we want in our agent, which is kind of just the read-only, kind of adds that extra layer of security so we can not have the agent writing to things or doing things it shouldn't. We're only going to do the read-only tools that GitHub exposes.
Yeah, absolutely. Yeah, that was a really great overview, Jack. And I think it's something we're not covering a lot here, but there is a huge question when using tools of what are you exposing to your users and making sure that you're doing things like propagating off properly. And so this is just one example of a gate we can introduce in an agent, which is just read-only tools only.
One other thing I just wanted to say, it also actually helps improve the accuracy of the agent as well. Because if you do expose, hundreds of tools to your agent, it can actually have a really hard time trying to figure out what tool to use when. So I always recommend only giving access to the tools that you need. It'll actually also help improve the performance of the agent itself.
Yeah, that's a super good call out, Jack. Yeah, and we'll cover this a bit at the end, but it's also important to tell the model about the tools because, for example, here we have a couple of search related tools. We have something for Google search, which we called search agent. We have a tool here called search issues. And then I think we also have the search issues in our internal bug database. And so making sure the model knows what to call and when is super important. And we do that through system instructions and prompt engineering. Okay, so that is the GitHub MCP server. Let's walk through another example of MCP in the context of a database use case. And we are here like from Google Cloud, so like let's pick a Google Cloud service to integrate with. And a natural one in this example would be a database, like an internal bug ticket database. In our case, we're running that in Cloud SQL Postgres. And so how would we connect to a Cloud SQL Postgres database? In the traditional application world, again, we might have an ORM like SQL Alchemy if we're using Python, and we have some integration code and some connection code that might take a while to like write and maintain, and we'd use that to securely connect to our Cloud SQL database. Instead, we're going to use an MCP server in this example. So Jack, do you want to walk through like what the MCP Toolbox is and how we're going to be using it here?
Yeah, so MCP Toolbox for databases is an open source kind of MCP server for databases. It's in the name. And it doesn't just support Cloud SQL or Google Cloud databases. It also supports open source, so open source Postgres as well as Cloud SQL Postgres, and a bunch of third-party databases. So that's really important to call out here. And the way it works is essentially you will deploy this server and it will manage all of the best practices like connection pooling so that you don't have to pull that into your application code. And you will go ahead and do a configuration file, a YAML file, where you actually go ahead and describe the tools that you want it to have. And these are essentially kind of, SQL statements so that you can go ahead and say, I want you to go list the open issues in our bug database that are assigned to, Megan or Jack. And we can do different tools. So we can go search by priority, search by assignee, things like that. And these are basically, we are doing this in a configuration file. We're saying here is the statement that you execute when this tool is called. And that's going to be done, again, on this MCP Toolbox server. It's not in our application code. And it handles, again, the connection pooling and all that database connection for us, which is really cool.
Yeah, absolutely. That was a great run through, Jack. Yeah, I think one thing that I really like about the MCP Toolbox is that it allows me to declaratively define my tools. And so if you imagine like a world with like ORM or just doing this through code, this is just like kind of a YAML file where we're saying like these are the types of tools that we want to implement, and there's a description for them. And so like I found it pretty easy as we like built out the types of bug tools that we wanted to kind of add them in here. And again, like you can swap out different database configurations as well, from local to hosted. And we can kind of see this in action. So Jack, yeah, do you want to run through this Toolbox sync client and how we're connecting to that MCP server from our code?
Yeah, so the MCP server, that you can either run it locally or deploy it to a serverless environment. And the Toolbox folks actually have an SDK for Toolbox in Python. So that's what we're going to be doing here in our code, where we're calling the Toolbox client. We're passing it, the URL to where our server is running. So it's going to by default go to localhost, but it could also be deployed in Cloud Run, which you'll see later. And then we basically just tell it which tool set we want to load in. So this is, again, in our YAML file. We can say, each tool set has this many tools, and you can customize it so they can have different tool sets. So again, if we have one agent that is our bug agent, it's going to have access to our tickets. We could have a different agent for travel or different tables, and they get access to different tools. So really nice feature. So we're loading in our tickets tool set. And again, that's basically it. ADK has support for this out of the box. It's really nice.
Yeah, absolutely. And I'm just going to do like a quick search here. So, just a quick search on our internal tickets. And so that's going to invoke the search tickets tool. This is actually doing a similarity search. So we have created an embeddings column from our bug descriptions. And so this was doing like essentially a fuzzy search within our Cloud SQL database. So yeah, that's the MCP Toolbox in a nutshell. And so let's just kind of pull all this together. And so that was a really fast tour through 5 different types of ADK supported tools. And when we combine all of this, what we have is a single agent. So this is a single LLM agent that where the Gemini 2.5 Flash model is making the choice about when to call these different tools and tool sets and why. And we'll quickly show you the system instructions, because I think, as we said earlier, that's really important that we're equipping our agent and the model with instructions about what we want the bug assistant to do, and then the tools we're providing. Jack, any things that you want to point out in here?
Yeah, I would point out that this is actually kind of I find myself spending a lot of time in the kind of instruction part of it. It's really important to get right. And again, like you said, when you have tools that could be called similar names, like search issues versus search tickets, it can really help your model to understand when to call which tool by giving a bit extra instruction, which we're doing here in our system instructions, as well as kind of saying when to follow up and ask more questions, when to clarify, when to not hallucinate. So really, I think trial and error here sometimes can be the best approach to make sure you get it right, and running it through different evaluations as well.
Yeah, absolutely. And evaluation isn't something we're going to be covering a lot in this video, but like hopefully like more content to come there, because it's a super important part of like making sure that your agent is doing the kinds of stuff you want it to be doing in the order you're expecting it to work in. Yeah. Cool. So that is that's the bug assistant agent. You know, we have the code for this all built out, and we'll include that in the description of this video. I think that the last thing that's worth kind of calling out is that we showed a largely local implementation of this agent, but this entire thing can be deployed to Google Cloud, and we have that pulled up here in Google Cloud. So like, Jack, do you want to kind of run through like what different Google Cloud services we're using here?
Yeah, for sure. So yeah, we have this, and again, in the instructions in the code, but we have the instructions for deploying our ADK agent to Cloud Run. And that really is nice, because then we can have, different teammates all using it. We can really kind of share it out and have our agent run not on everyone's machines, not having everyone having to run it locally. So that's one thing. And then we also have Toolbox deployed to Cloud Run service. Toolbox is essentially, again, just a server, so it can easily be run on Cloud Run. Again, sharing it out. That way you can deploy one server once, you can connect to it from different clients, different agents. And then, yeah, we have all of our external tools, like our Stack Overflow, like our GitHub, and those are all just being called over the internet. So again, we're kind of pulling it all together. I think maybe we can just quickly touch on, we've got GitHub external tickets, we've got Stack Overflow being queried, we've got our School Search, we've got, all these tools really allow you to pull from everywhere, from internal ticket databases to external issues to do research. It's quite powerful when you actually look at the code. It's pretty short for doing all of this capability, and that's just a kudos to ADK and making these tools super accessible and easy to use.
Yeah, absolutely agreed. It's like funny because we built this as a sample agent for ADK, but like I don't know about you, Jack, but like helping to maintain certain repos, like I feel like I might actually try to use this in my real life. Like it's really not just a sample in the sense of it's actually pretty helpful. So yeah, thanks, Jack. Like that was a super great overview of tools and MCP and all the different tool types. Anything that we want to kind of like wrap up with, or like sort of key things to remember about tools here?
I think it's really just experiment, figure out what you're trying to solve, and then figure out how you can use tools to your advantage, figure out what your agent's supposed to do, and then figure out how you can equip it with the right tools to go out and achieve those outcomes, because there is endless possibilities out there, especially with things like MCP. It's quite easy to spin up your own MCP server and give even more tools to your agents.
Yeah, absolutely. I think that the thing that I try to remember is like, and this goes for pretty much anything agents related, is to just start simple. And like, here we're not doing any fancy multi-agent or any fancy patterns. I mean, we got all of this done with just a single LLM powered agent, with some pretty specific system instructions. So, but even then, like, yeah, start with a function tool, a built-in tool, maybe pull in like a LangChain or crew tool, and then maybe wade into MCP, because especially when it comes to building your own server, yeah, like getting started is pretty quick, but it can get somewhat complex, and there is a little bit of a learning curve with DIYing an MCP server.
Totally.
Awesome. Well, Jack, thank you so much for this awesome run through. It's been great to chat and to work on all this with you. And yeah, hopefully we'll be back soon to talk about more agent stuff.
Thanks, Megan.